Hi, my name is Konstantin. I'm co-founder of a company called Intento. We're located in Berkeley. And yeah, thank you for this opportunity, because I would say that for me, the main thing is to get feedback from you. So that's why if you want to provide your feedback, do it right away without waiting until it's over. Just ask questions. I will try to just describe the experience we have with machine translation. You may have different experience. Please share. I will try to do as few generalizations and conclusions as possible. If you hear any unjust conclusion, please tell me. Yeah, and I'll be talking about evaluating domain-adaptive neuro-machine translation. And here's a little bit of terminology which may be different from what you use. And I will call like stock MT or pre-trained engines, something which was trained and you use it like as it is off the shelf. And domain-adaptive is, you have custom MT which you may build from scratch. Domain-adaptive is something where you give this engine your small data set to sniff, like a cloth to a dog, and it immediately understands not immediately, but quickly, what's your domain and improves the output. So that's what I call domain-adaptive, and I'll be talking about that. So I will start from describing a little bit what our company does to explain why we evaluate machine translation, how we came to that, and also to explain angle to which we sort of look at these things. So we started a couple of years ago. We built like a universal API middleware which can integrate with REST APIs very quickly, automatically. And we were looking for markets where abundance of APIs and difference of those APIs creates lots of friction. And we had an idea that AI as a service and machine translation specifically is one of such markets. Because we looked at the price range, we noticed that machine translation price is 300 times different, which means there's some friction which prevents people from evaluate all the options and switch between vendors. Understood? We went to look at this more closely. And then we decided to run an evaluation, quality evaluation, to understand, is it only about like price and maybe a language support, or there's something more? And we found that actually we evaluated on very few language pairs, like 11 language pairs, probably around 10 engines, and we found that the performance is wildly different. And this like quality ranking is very different based on the language pair. And also we found that even if in some cases like this score difference, like blue or something else, maybe it's small, perceived quality is very different, at least for the languages we know. So we understood we're really like onto something, and we built like universal MT middleware where you can through like single integration talk to all these engines, and we started to help companies which work across many language pairs. That was we worked back then. We worked with only stock engines, so it was mostly about general purpose content, non-mission critical content. That's why we use very simplistic approach to evaluation of these systems. Just not blue score, Lipor score, but it's more or less the same. And another thing we noticed that these quality rankings, they also change very fast. So just to provide an example, like that's two latest, these general purpose evaluations when one disclaimer I forgot. I will mostly not name the names in performance comparisons because it's very project specific, and I don't want to give any, I don't want to mislead you saying that, look, hey, this brand is better than that brand, because that's for some specific case, right? I will just show that in color. So those are like 34 language pairs in July 2018, best engines. And best meaning they're significantly better than others, like statistically significantly. And then that's in January, like 5 months later. It's still, you need to have like 9 different engines to get the best quality on general purpose domain, like Muse Corpora. But those are very different 9 engines. Because lots of things changed across these 5 months, like Amazon added new language pairs and rolled out next-gen engines. DeepL added language pair. Microsoft rolled out new technology. Yandex halved price twice and improved technology, and so on. So it changes really fast. Okay. And then actually, there was sort of a breakthrough in 2018. And this is the emergence of this affordable custom neural machine translation. And I would say that this, like, by significance, it's almost as invention of NMT itself. Because before, like, I would say before, like, last summer, you could either use stock engine or just build your own custom NMT, which was very expensive. And now this technology, so where there are some baseline model, either baseline model or some stock corpora, and a way to find which of these corpora is similar to your data. So you can provide a relatively small amount of data to train like a decent NMT engine from scratch into around probably 10 million segments, data points, parallel segments, to adjust model, DomainAdaptive model to domain, you need starting from 1,000, which is like ridiculously low amount of data. Then these DomainAdaptive systems, they typically have lots of like linguist work automated. Because the reason why custom NMT is expensive, because you need to clean your data, align your data, filter noise, then turn different knobs to calibrate the model to your specific project. And in these DomainAdaptive engines, many of these things are automated. So you just upload your noisy real-life data, they do realignment, they do cleaning, they pick some sort of different mix of technologies which they use inside just for you, and you just get, it's like one button experience. That's why it's much, much more, much less expensive. And typically you pay for computing time here, while the main cost driver for custom NMT is probably human effort, like linguist effort, and data scientist effort. For DomainAdaptive NMT, it's like electricity. That's way cheaper. And like over 2017, this number of engines emerged. And so just this picture is based on marketing materials, meaning that I cannot really show what I think like is when they actually launch something, if I know that in private information. So those are some links to marketing materials when they say we'll launch our new DomainAdaptive engine or something like automatic custom NMT. It's up to you to check how this marketing compares to real life. But that's a timeline which I can show. So it's GlobalEase, then Lilt, sort of adapts on one sentence which you send there, then Systrun, Microsoft Custom, IBM Custom, SDL Enterprise, Google AutoML, and Modern MT, which also adapts on starting from single sentence. Lots of things. And we got a question, sort of, when we run our evaluations in the past, we were like stock engines, we were trying to evaluate custom NMT as well. But when we were approaching custom NMT vendor, they typically told us, well, there's no reason to evaluate custom NMT. Because, we just look at your data and we build the best model, period. Why do you want to evaluate this model if it's the best one? No reason. So we also we got this question like, should we evaluate DomainAdaptive and MT, or maybe you provide your data, and all these different baseline models they just adjust to the same good level. So we had to run this evaluation to see what's there, and also understood that it's a different use case. For stock engines, it's typical non-critical content, no post editing. So it's one thing. For DomainAdaptive, it's typically post editing scenarios because they're domain specific. So the ROI is about reducing post edit effort, and you cannot really evaluate it without looking at this how post editors work and what's the workflow and without people. Well, you can maybe, but we didn't know how to do that. And there's another factor which we found. So one thing we found that there is a new dimension of difference between engines is their learning curves, how well they improve over your amount of data. And as you see, some of them actually start high, but improve a little. Others start low and improve fast. And here they don't cross like on 500,000 data points, but we had other projects where this engine is like goes not to here but to here, and then flattens. So like if you have 10K, you would pick maybe this one, and when you have 100K, you would pick like this one because it improves. And ultimately, we found that yes, it makes sense to evaluate them. So we ran this first evaluation report on a single language pair, single domain, which is like life sciences, English to German. We found several interesting things. So this green is a number of ideal segments not touched by humans when they were doing blind review. This dark red is something really bad, and this in the middle, it's like in the middle, different shades of post editing. So we found that like amount of perfect segments may be really different, amount of bad segments also really different, and also found that there are complementary engines. So if you combine like these two, present it to editor to choose between them, you can much more good segments and much less really bad segments, because different engines work differently on different sentences. And
question.
Yes, sure.
In the previous slide,
Let's try to get the questions on microphone so they can hear you. Here you go.
Oh yeah, there. What does the y-axis stand for?
So y-axis like score, and this is how much data you have. This is like stock model, baseline model, and that's you train this, adjust this model with increasingly more data, and you see how performance improves.
So the y-axis is kind of
Score.
comprehensive score.
Yeah, that's we calculated without humans because it was like many experiments to see how it improves. It's like Lipper score, blue score, reference-based score. Yeah. Yes. So we ran this first study in November, like 4 months ago, and since that time we run probably around 30 or 40 projects, like different evaluation projects for different clients to help them understand. So we got some insights which I actually want to share. Again, I will try to just rely on the experience without any conclusions.
Question.
Sure.
What is good all-round stock and MT?
Well, I wanted to say that this is not some bad engine which we pick specifically to show that how bad MT can be. Millions of people use this engine. I'm not naming what's the engine.
And what is the difference between, in terms of time and effort, between the stock and the one on the left and the good all-round stock MT?
So the differences in how many segments were left by post editor without any edits,
Oh.
share of the segments,
Oh.
and how many bad segments, how many segments postator told it's like showstopper. So yeah, sure.
Could you try to enunciate each syllable? Because when you talk fast, it's kind of hard to hear it.
Okay, I will try. Thank you.
Better.
Thank you very much. I will try to do it better. So I will I will just describe the evaluation process which we came to. It's not always all the steps in every case, but those are most typical steps which we have. And that's first, well, figuring out what are the goals, why we are actually comparing engines, what we're going to get from that, from selecting the best one. Then identifying set of projects, basically how many engines you're going to train or select for your whatever business. Then how we pre-select candidate engines, which we will be comparing for quality, because quality comparison is not cheap, or not free at least, and this is very lightweight procedure. Then sort of ideally, we would just pick those candidate engines, run translations, and give them to humans to review or to postators to post-edit. But to make it statistically significant, it's like 2,000 segments, 10 engines, 20,000 segments for one language pair, which for human review is around like probably $20,000 and maybe several weeks of time. We can do that. I mean, we venture-backed startup. We can do silly things. But we decided not to do that because it's impractical. No one will do that in real life, except maybe venture-backed startups. So we decided to find a practical approach to that. And we looked which LSPs are have some good transparent approach to LPA. We discussed with several of them how it's better to do that. And we worked with one company for this initial evaluation. And since that, we work with some others. What we do, first we do large-scale automatic scoring when we select like top ranking engines, or more like filtering outsiders, and we select different subsets of content based on this score for human review. But instead of like having 20,000 segments, it's like maybe 200 or 300 segments. It's much more doable. And then there's optional things. One thing is that we typically identify complementary engines to understand, okay, we found this good DomainAdaptive engine. If there is a good stock engine, which is complementary, meaning that it translates some sentences much better than this DomainAdaptive engine. And second, but that's next step for you as MT users is, well, probably engine selection is like 30% of the deal. You have to set up proper workflow, you have to train people, and you have to track performance, how your post editors use, like how they post edit. Actually, it's interesting. How many people here use machine translation in production? And neural machine translation, same. And how many of you track post-edit effort, meaning that like time spent or how many segments are untouched by post-editors? Good. So that's this like a pyramid, and we'll touch these things. So I will go just the steps, and well, I will explain what we are looking for, or what you may look for when you do that. So first, in terms of the goals, it's very important what's the use case. So far, we've seen three main use cases. One is post-edited machine translation, when your goal is to reduce cost and time turnaround, typically in order to translate more content, because for typical company, they translate just a little bit of what they want to localize. Then second is raw MT, like when machine translation results are used without any post-editing. In this case, you typically want, on one hand, the best quality, because there will be no human fixing those mistakes. On another hand, you don't want critically bad errors, because no one will fix them. Only annoyed users will tell you, maybe. And then, if it's a large-scale project, then you also want to optimize costs. While in post-editing case, I mean, MT cost is negligible. It's just a small fraction of post-editing effort anyway. And then another case is information retrieval. It's situations like e-discovery, litigation, some patent search, pharmaceuticals, when you have to translate content just to apply some other NLP technology after that, because this NLP technology either works better in English or you just need to do that cross language. And in this case, fluency is not so important, but typically you look for making it cheap and being able to produce large volume of that. There's probably one case I have not mentioned here is this real-time versus offline. If it's like chat translation, then you want this engine to be really fast. Yeah, then how mission critical is that? Is it like inbound content or outbound content? And based on that, how would you calculate ROI of this procedure of optimizing machine translation or just investing in machine translation? Because if it's post-editing machine translation, then probably any single-digit percentage impact from using machine translation, your ROI will be very high if you reduce this human effort. While in cross-language information retrieval, it won't be the case probably. Then what gains do you expect from this applied machine translation? And what another option you have if you don't do that? Is it just humans doing all the job, or you have some engine in place and you're looking to improve that? What's the situation? If you know other cases, please share, because we learn some new flavor probably every month. Maybe you can share some of that. So then the next step is to identify like how many engines you're going to train, or for how many sub-projects and sub-projects you need to evaluate. And we approach it very simply. So like if you have a translation memory for this project, then probably you want to use another like distinct DomainAdaptive NMT for this project. And here this idea that DomainAdaptive machine translation is just a better way to leverage your translation memory. It's very proper idea. So just approach it this way. If you have TM gains, then try to improve them by applying machine translation. Then it's good to be conservative. So if you're not sure if it's two different projects or one, you can just evaluate it as one project, and then you can look at the error matrix for this data set. And if you see that you have more errors on some sub-project, then probably it's a different domain. And if you track productivity over time, then when some new project emerges and it has much worse productivity than others, probably it requires a separate engine. So something wrong there. Then for every project, there's a number of attributes which define what engines may be applicable. So what are them? First, it's a language pair, obviously. Then it's a domain. Then availability of reference data. So what you will be comparing against during scoring. Then availability and volume of training data. And here I put them separately. Like in the ideal world, you just take your training data and just take a sample of that as a reference data. In the real world, that's a very rare case, surprisingly, because the real world translation memory is not very high quality one. That's one situation. And you need to clean it up before using it as a reference, because you may have mistranslations, misalignment, fragments, too much localized or stylized translations, and other bad things. And as I mentioned, those DomainAdaptive engines, they have these tools to fix those problems. That's why you probably should not over-invest into cleaning up this large volume of training data, but you probably should invest in making good reference set for evaluation. And another situation when they're different is when you're trying to use training like TM from one project to build engine for another project. And samples may be you have manuals and TM, and you want to use that for your community portal for Rowan team. Then you pick training data from one project, but you cannot use it as a reference because you'll be using that for a different project. And it may be different content type, it may be conversational, while your training data is like formal materials. You still can get improvement, but you cannot use it as a reference. You need to use different. Another example, you may have training data in Spanish, and you may have a project for Latin America. And so you may use it as a training, it will fix some terminology errors, but you cannot evaluate on this data. You need to evaluate on exactly the dialect you're gonna translate it to. Sure.
Hang on, Tex.
Hurry up, Joe.
Tex makes me run all the time.
So if the available data that you have to begin with is, as you described, not high quality, and the suggestion is to train it, is to go through and invest in creating higher quality data, you're essentially trying to drive this project to produce a standard that's higher than you currently have. Shouldn't the goal be to be at the same level of quality for comparison purposes, rather than trying to invest in producing a machine that produces some high standard, which you haven't been achieving in your current activities? And so maybe you're being over discriminatory or over perfectionist in what you're trying to do, or maybe that's a factor in your investment that you're trying to do more than what you currently have, and then your end result is you're comparing against a false bar. You've raised the bar for what you need.
Well, I think that overall, yes, that may be the case. I can explain how it looks in practice. In practice, you run this scoring on this real life data, and you see that some of this data, it shouldn't be there, because you shouldn't be evaluating your machine translation system on this sentence which is mistranslated, because it's misleading.
But you've been using it all along. I understand the point. It is you'd like your machine to be correct. On the other hand, your human translations for your existing process wasn't very correct either.
But maybe we can do better exactly because of the machine translation.
Yeah, but then you have to factor into your ROI here that you're actually changing what has been acceptable. It's an important factor, I think.
Great.
The other question I have, as long as I have the microphone, for the post-editing, I'll make this the last one. But for post-editing, who decides, what's the process around a post-editor deciding whether or not they should do more post-editing? Because that, if you leave it up to the post-editor and they're getting paid for the translation, they have an incentive
Right.
to do much more editing perhaps than is necessary.
Well, that depends on lots of factors. I mean, on how you pay and other things. But I'm not an LSP company, so I will describe how we do that for evaluations, but I cannot describe how LSP is doing and what they are doing to avoid this over editing. Well, they do something. I would say that although that's one of the reasons why when you use machine translation as a buyer, I think you should have pretty good transparency into this process. What actually you get from machine translation and what you get after post-editing, what was changed. So sometimes, and I think on a translation technology roundtable, we had this example when some company, well, on their slides they had confidential, so I won't tell you what's the company. They introduced custom NMT, and they got a spike of post-editing. It turned out that like 3 years ago, they sent this style guide, and it was strictly followed. While it started to be unnecessary with machine translation, but post-editors still, they made these edits. And we had this in our experience as well, where the client, so they're producing some materials for rural areas of Mexico. And they had a style guide that the named entity, after translation to Spanish, it should be repeated in brackets in English. For these people who don't speak English in Mexico. And for them, the question was that, do they want to pay several $100,000 more to follow this style guide? Because MT, there is no way machine translation will follow that. So you have to edit that. Or maybe they can just give up on the style guide. There are all sorts of these choices.
Yeah, and the other factor is if you're using LSPs and they see you're testing machine translation, they're seeing their translation volume going down, so they're going to move it to post-editing.
You know, I think it's a good example of what's called Julian's paradox. It's a thing, they invented it for call, that when you drop the price of something, the consumption increases and the overall budget increases. So at least for many companies which I talk to, that's the case. They translate X million symbols, they want to try words. They want to translate 20X words. So that's not necessarily about like reducing budgets, I think.
Thank you.
Yeah, then availability of glossary, because some of the machine translation engines support glossary adaptation. And then a number of, I would say, like meta attributes. It's more like about your business than about specific translation project, but it still influences your choice of technology. So data protection, what do you require? Is it like, are you okay with sharing this data with the engine to improve it for other clients? Do you want it to be confidential? Do you want it to be no trace? And increasingly more the case. Then data locality requirements. If you translate personal data, then in the world there is around, I think from 15 to 20 regions with data locality legislation where you cannot drag this data out of the country to translate it. So you have to select the MT, which has data center in this country. Then contracting requirements, because in some case you can sign contract only like being in that country. Like to use Naver, you should be Korean entity. Sorry, even if it's good at Korean, if you don't have this entity, you won't be able to do that legally. And then payment options. For many Chinese engines, you can pay only from Chinese bank account. So you have to figure out that. Then deployment requirements. Is it public cloud, on-premise, or all the space between, private cloud, and something else. Then user scenario. So what's your monthly translation volume? What's your peak translation volume? And how often you're gonna update your engines? Because all engines, they have different like total cost of ownership models. And based on all that, you may select candidate engines. So which are different by language support, by do they have domain and dialect specific baseline models? So something you start with, is it, can it be specific to your domain? Do they have something? And that's actually very, for example, if you train for Portuguese European, Portuguese, you'll have hard times doing that. Because for most of the engines where they just say Portuguese, it's by default Brazilian. Or again, the same for Spanish, Spanish Latin. By default, it's Spanish. For some engines, it's actually Latin, but they are not telling that. So you have to figure out that. Minimal training data requirements, which range from 1,000 data points to, I think, around 20,000 on the lower bound. Glossary support, which is increasingly the case out of domain-adaptive engines. Currently, I think IBM, Microsoft, and maybe that's it, which support glossaries.
Do you consider glossary support already domain adaptation?
It's different. So for some engines, it's a part of domain
adaptation.
adaptation.
It does have glossary support, but doesn't have any
Microphone.
Can you guys, well, maybe you could just repeat kind of his question.
Yeah, so the question is glossary supported domain adaptation? And it's different. So for some engines, it's part of adaptation process. For others, they just put it on top. And some other, they say it's a part of domain adaptation process, but they don't really use it. They just add it to your TM, so that's not effective. And others, they tell is a part of the domain adaptation process, but in fact, they add it on top. So again, you have to figure out that. How it happens for your language pair. That's very different. Then data protection, deployment options for regions and for installations, like it's in premise or cloud. Yeah, I mentioned actually all that in the previous slide. So all engines are different, have different values of those attributes. And you just have to filter them before you go into using them, evaluating them. The way we do that, we just have sort of database which we slice. Yeah, and also these things are updating. So they're also changing, language support changing, regions changing. So how we do that, we sort of automatically monitor their documentation. And when there is some changes in some sections, we got notified and we update this. So what are you changing from? On this slide, I put all empty engines which I know. There are some of them which we never evaluate and we never deal with them. With some of them, we deal in a situation when it's an existing engine and we compare something to this engine. So many of them are stock, some of them are custom, some of them fully custom, like I think Omniscient, Pangea, Promzit. There's no domain adaptation. You just have to train it from scratch.
Hang on a second. Let me get the microphone to you here.
You show the eBay engine in stock. I'm not sure.
Yeah, by stock I mean pre-trained. I just use this pre-trained. So you do not give your data to improve it. You just use it as it is, like Google Translate, not AutoML.
Okay.
I call it stock.
You have no capacity to adapt it yourself.
Yes.
Ours is customized to our content, but we don't allow for you to do it outside.
Yes.
Okay.
For some systems, I think some of the SDL and Systrans systems are their stock. If you want it customized, you can reach them and they will do that for you. So they have this customization option through like professional services. And just a number of engines which we typically working with, just to explain how they're different along all these dimensions. So for example, GlobalEase, so GlobalEase works on data augmentation model, meaning that they don't use transfer learning. They take your data, they pick lots of stock corpora similar to your data, and they train engines sort of from scratch on this augmented data. They have very rich like stock corpora. That's why you can actually find very specific dialects there. They can be deployed like cloud and on-premise, and there's no price to train. There's cost to maintain, like 50 euros per month, and there's no cost of translate if you use low volumes. So that's one business model, which is possible on this market. Like then there is Google Cloud, which supports. I think maybe it was in like November, October 15. I think now it's around 100 or something. You can customize it only with parallel corpus as of today, and they use like transfer learning technology. So there is some baseline model, which is probably similar to Google Translate, and they adjust this model using your data. And yeah, and those language pairs, actually in almost all of those engines, it should be with English. It's either from English to something, or from something to English. So despite of all zero-shot technologies, you can adjust if you don't have English. Maybe now it's changed if some reason changes. And here you train per hour. You don't pay for maintenance, and you pay for translation around 4 times more compared to their stock engine. Then IBM Cloud, which is relatively unknown because IBM does not spend on marketing their machine translation. Around 50 language pairs. Actually, they support glossaries. Deployment as Google only in the cloud, and with optional no trace. So you can, if you pass specific API parameter, it's no trace. If not, sorry. There's cost to maintain. There's no cost to train. Actually, it's one of the, I think, few engines which you can train as many times as you wish. Quite expensive to translate, $100 per million symbols.
How much trade does Google and other?
So Google takes per hour.
How much can you train in an hour? Can you kind of transfer
They have
into volume?
They have some table. I would say that on. I will tell you later. I have a slide about that. So then Microsoft Custom Translator. Actually, it went. I think it went general availability recently, so it's a little bit outdated. Language pairs, you can use glossary since recently, only in the cloud with no trace by default. $10 per million to train, and they recently made a cap. It's capped by $300, regardless of if you train on large corporate. Because they understood that it's impossible to budget a training of the engine which is not capped. And I hope other providers will figure out that as well. Cost to maintain, I think $10 per month, and cost to translate $40. So then Modern NT, which is an interesting engine, they use very specific technology, I can't even comment. They told me that it's different from what described in their patents and from their articles and in their source code. It's very, very sophisticated, good technology. It learns on the fly, so you can make it learn on every segment post-edited. It can be on premise. Yeah, to train it's free, to maintain it's free. and but it's very expensive to translate in their base tier. If you go on premise or if you go volume contract, that's a different story. Then tilde, which is good, I think, at Baltic languages. But what we figure out, work evaluating them, they actually use human effort to train the model, although they don't price it as expensive as other like NMP shops. Can be cloud on premise, and everything else is depending on your probably annual revenue. Yeah, so pricing, that's just comparative table. Again, it may be a little bit outdated at some places. Yeah, like Yandex recently reduced their price twice. So that's a range for stock machine translation from like $3 to almost $1,000 per million. Well, these two actually priced in words. So this is not very, it's like estimation. Wrong direction. And in terms of comparison of how much does it cost, like that's a cost to translate with DomainAdaptive NMT from well, sort of free to modern NT, then cost to maintain the engine, and cost to train the engine. And that's what we seen in this our evaluation report. It's like 10,000 symbols, like in case of Google, it's around $200, and it will go. Actually, we haven't trained on larger volume, but you can have an idea. So language support, it's about stock engines, not about DomainAdaptive. So for DomainAdaptive, it's much fewer. For stock, some engines support thousands of language pairs, tens of thousands, around 10,000 largest. While in DomainAdaptive, it will be in the range of like 50 to 100 most, I think.
What is unique?
Sorry?
What is unique? Unique?
Unique for stock. So we, if it's a language pair available only in this engine, how many such language pairs? So for example, like in IBM SMT, I think they have Egyptian Arabic, only that. That's unique language pair. But SMT is deprecated. So for example, for Yandex, they have 1,000 unique language pairs where you cannot get in any other language, mostly related to Eastern European and CIS languages. Like for Google, they have like 3,000 unique language pairs and so on. Then, when we selected those, I'll just check. When we selected those, I'm over time already. Sorry.
You got 10 minutes, 40 minutes. How much time do you want?
Okay, we'll see. So then when you selected the candidate engines, then you go for quality evaluation. And there are two approaches which often seen as a dichotomy, right? You either do automatic scoring or you go human. And human analysis, you don't need reference translation. Identify all types of errors, very labor intensive, expensive and slow to run significant tests. So you can, at what you can end up, you can pick 50 segments just randomly for a corpora, and you can just pick bad segments by random, or segments which are translated similarly by all the engines, and you will drive some conclusions out of that, which will be not very good. And reference-based scoring, quick, cheap, statistically significant, but you need reference translation. It's very relative since it's just distance from human translation. So more or less it's good to identify outsider engines, but it's not good to identify the quality level. And what we found, what we use, we combine them in the way that we run automatic scoring on scale using segment level scores, so we can have some insights into what segment, how segments are scored. then we filter like outsider engines, and we extract meaningful groups of segments for human analysis, which optimizes this evaluation significantly time. And that's one of the reasons why it's good not to use blue. Blue is a corporate level metric. If you use blue, you have no idea why blue. Like why you trained your engine with more data and it started to be worse. You have no idea, you just see blue score decreased. You don't see the segments which contributed to that, and that's hugely important. That's why we use, so for automatic scores, we use typically 5 of them. That's what we use the most at Sleepor, which it's sentence level. It combines recall and precision. It feels like intuitive, at least in the range like between 0.3 and 0.7. You see like Sleepor 0.7, okay, it's like 70%, sort of, 30% bad. Then there's TeamR, edit distance, which is, some companies like that because it sort of reflects editing, but it's not weighted, meaning all edits are treated similarly. So that's not very good. There's blue, and one of them, well, blue has some problems. One of them is that there are lots of different blues. Amazon made very good effort. They built Sacred Blue, which is like gold standard blue score. But still, blue is precision-based score, meaning that it's good to find omissions. It won't probably as good to find additions. But you can complement it by a score called Rouge, which was built for text summarization and which is pointed exactly for additions. And then there is RIBES for attack languages, for Japanese, others. So what we do with them? We look at 2 things. First, we calculate on corpus level, and we see how correlated they are. Typically, they are correlated between themselves. If there are some uncorrelation, that's an indication of very specific type of problems. If you're like Rouge somewhere is better than blue, or worse than blue, then there are some additions which are not caught by blue. And basically, any uncorrelation between scores, it's a reason to look into that more closely. And we use the most Sleepor. We calculate it for first. We'll look how confidence intervals change with increase of this reference data set. Again, we can't do that because it's a sentence-based score. We can calculate confidence. And we see that typically it's better to use from like 1.5 to 2,000 segments for the scoring, just to make sure that your reference set is representative and you may be confident in these results. And then, so we calculate average scores. From the average scores, we basically, frankly, they're good for only one thing, putting engines into buckets. Probably good engines, probably bad engines. So on this picture, this one's probably not very good for this language parent domain. This one's, well, they are probably more or less similar, good. The final decision should be like made by human person because it's domain-specific translation. There's subject matter expertise and other things. So then what we do, we look at the mean scores for every segment across all engines. Basically, it shows sort of difficulty of the segment. Like some segments are badly translated by all engines. It's about reference data. And typically that indicates problems in the data. Because if you have mistranslated segment in your reference data, it will have low score for all engines. Also, issues with training corpora, style guides, so localized segments, and also quirks. I will tell about quirks later. But the thing is that every NMT engine, which is based on deep learning, it has quirks like humans, something unexplainable, strange behavior, which you see in some situations. And then we identify several subsets of reference data to look at with eyes, human eyes. First is these worst segments to identify those problems. Well, second is actually best segments for the cases where you need to understand how good it may get. Like if you're translating marketing text, then your first question is not how bad it may get. You know that, maybe really, really bad. But how good is it? Is it good enough to use for anything? So then you would look for the best segments. And what we leave for LQA is segments which are sort of medium, normal, in this normal distribution, but which are translated very differently by different engines. They highlight these differences, these systematic errors which are made by certain engines. Yeah, about quirks. It's just a collection of anecdotes which you found over a course of evaluations. So we know one engine which doesn't translate anything about Jedis, period. Empty translation. Jedi in sentence, no translation. It's a very good, otherwise, very good Chinese engine. Don't like Jedis. Another one, when it sees search engine optimized text, it decides it will fix these strange things, so it translates with a single word. Actually, they already fixed that, but it was the case. And their SMT version worked just fine. Their NMT version did that. Because it's NMT, it's like human. Another one, that's actually very, very weird, because I understand why did it happen, because engineers use Hello World to test. But when another engineer tries this engine, that's the first thing they put into translation, and like, what? Okay, there's another one which, if it sees some numbers, it decides it will add some on its own. So it adds, it's a revenue profit. It adds EBITDA, because probably it should be EBITDA with some number. I have no idea where did you get it. Yeah, another one just rounds up correctly, no problem, but by some reason. Another one, it's interesting. Some people will tell you that you can safely give them your data for training NMT because no one will see this data because the training process is so complex. So there's one engine with H URLs to your translations with SKUs. So there's a text about some medical device. It adds URL. You click this URL, you see heavy truck. Yeah, then one company recently, they improved their NMT and they went from word level to subword level to character level. Overall, quality improved, but for some specific languages, language pairs, they started to mix letters. Because probably those letters are sort of statistically close, so during this training, it happened this way. Well, we told them that. Hopefully they fixed that. So yeah, so that things, you have them. You will always have them. One of the reasons why I would not recommend you train your own NMT in-house, because you'll die fixing these mistakes. There's no any company which use pure NMT. Pure NMT, it's like a kid with behavior problems. So then for the subset of data, we do human evaluation. There are two types of that. So it's a priori, which is LQA, versus a linguist, fixing types of errors. And there is sort of hard evidence, post-edit effort, when you just put a post-editor on this empty output, and you carefully record all actions and time spent and things like that. For different cases, you may pick either of them. So with human LQA, I will skip this part. We found LSP with very good approach to LQA, like very simplified MQM DQF. We run scoring with error types and error severities. We found it's not very useful because people are very bad at understanding these shades of severity. So we simplified it a lot. We simplified it to what you have seen, to 4 buckets. Really bad, bad, I would use a different word, and I won't change anything. And interesting that that's human reference translation. So we all were surprised by that, and we analyzed what's happening. What we found, so, I mean, we talked to these reviewers. We found that that's because human translation typically is opinionated, it's subjective. And your reference data contains translation from different human translators. So when a single human reviewer reviews that, they tend to disagree with most of them just because they're much better translator than those guys overall. And with the, well, MT is sort of consistent. So once you made this person believe that it's MT, it's fine, it's not human, it's robot, don't really expect much, they stop to give this opinionated mistakes to find them. Yeah, and then we asked ourselves a question like, okay, let's go to the segment level. Are engines which have similar performance characteristics have it similar for similar segments or not? And we found that definitely not, because there are this engine translated these segments much better than this one, but this one translated this better than this one. So if you combine them, if you let your post editor select between these two, they may select a better one, reducing editing effort. However, in order to do that, you have to put a very proper workflow because people are bad at selecting things. If they use their, system 2, or which is more cognitively complex, they will spend lots of time just choosing between these two. So you have to think about that. Yeah, and there's another approach where you just monitor time spent during post editing. And if you don't have proper tooling, you can use some open source. There's that, which is quite simple and effective. And results are surprising. So that's what we do. I cannot show them because that's it's only private evaluations. But we see things like one engine, like DomainAdaptive and MT may produce twice more perfect segments, but stock engine, which is linguistically better, it may be much easier to edit. So if you want to get this additional improvement from combining engines, you have to think how to incorporate it into your workflow. So maybe you make first step, which is like validating is like custom and empty output good enough. If it's not good enough, go and edit stock and empty output. So it's a question. Yeah, actually I can skip the rest. Thanks. Sorry for yeah.
Yeah, some of them have really long drives, Oh, while I have the microphone, I want to say that Janice later typed in to remind me that the talk at SF Globalization will be about the Noto project for the Google Noto fonts, co-developed with Adobe. So right up Ken's alley here. That's on May 8th. Okay, and Tex is going to stand in for Merle today and do the final question.
Is this the final one? Because I had 2.
Oh, okay. So questions, plural.
Well, one maybe is more of a comment, which is when you look at the ROI, one of the things that needs to be considered, I would think, is the effect on your organization. You might need people with different skill sets in order to manage dealing with the MT engines, running processes like you're describing here, which are not the same as what they're currently running. So
Yeah.
It could mean significant change maybe in costs for people, as well as the deployment of people. It's not just a vendor issue. So that should affect the ROI.
Absolutely. And one thing I forgot to mention is that so there's actually a different approach to evaluation. When you have lots of traffic on your page, you can just skip this human evaluation. You can actually put traffic to do split testing. In case of raw MT, or if lots of post editors in live projects, you can do split testing on them without any additional investment into engines, into evaluation. So that's a way to do that.
Yeah, and then the other comment I had is everybody, when they look at MT, takes a very microscopic approach to which sentences, what segments are working, what's the quality. But I think actually from a macroscopic level, the criteria should be, did I produce a document that is acceptable? There may be some number of grammatical and other errors, but if the quality has enough technical accuracy and is more or less understandable or readable, you're probably getting close to the same quality that you get with a human translator, because they often have all sorts of errors as well. And so I sometimes think that certainly people who are designing and developing engines, or maybe doing comparisons as you are, need to take the microscopic approach that's used for these different scorings. But for people who are considering, for companies that are considering MT, it might be better to just say, what percentage of these documents could I go ahead with, and would it be okay? Because often the input that they're giving in the English, or whatever the source content is, isn't always that technically accurate or that well written. And then the other stuff that they're using for translation also has some number of issues. So I think some of the scrutiny is maybe the wrong type of scrutiny.
I have two anecdotes about that. So one of them is there are cases when one thing, you had another dimension. So one thing you look at is this post-edit effort or things like that. But another thing, if you use post-editing, that's humans do that. Humans tend to overlook certain things, just little mistakes. So for projects which are mission critical, like medicine, there's another dimension typically, how many there are critical errors. And clients like from life sciences, companies from life sciences, they don't even want to give it for post-editing, because they realize that it won't be subject matter expert, even if they're told so. It probably will be just speaker. And if this critical error, they would go with linguistically worse engine, not so fluent, but without such errors. That's why actually glossary support is super important. Second anecdote, we have one e-commerce client who translated product titles, and in e-commerce we have this problem of garbage in, because product titles, they are bad in the input. They are translated word by word from Chinese to English, and however good your machine translation is, until very recently, when there's one engine which transcreating appeared, it was very bad. So they wanted to make a split test to make human editing and measure the impact, how higher conversion they have, to estimate exactly how much they should invest into post-editing of maybe bestsellers or something like that. And what they found, that conversion dropped twice for human edited content. And they reached by phone these people, and they asked them what's happened. And users told them that they got used so much to these bad translations. When they see something really good, they think, okay, it's promotion.
Your base are us.
Yeah, you're promoting this, we won't buy it. So user expectations is also important. They're not always expecting high quality literacy, literal translation.
Train your audience.
If OCD like some of us, it has to be perfect, but for everybody else. Okay, so does anybody else have, oh, here we go.
So you have evaluated many engines from many vendors. You carefully studied which automated metrics to use to went for LibOR. You mentioned the RIPS metric for hieroglyphic languages like Asian languages, level byte. Have you, in your past experience, found big differences with challenges in measuring the quality of Asian languages?
No, I mean, we were told by some companies that we should use RIBS because they have seen in the past when it was different, like uncorrelated. We haven't seen that in our project. Moreover, I would say another thing, that we had several situations when a company sees that, so they run, like, they have 20 projects. They run first 5, they run human LQA after automatic scoring. They see how much does it cost. They see that it's completely correlated with automatic scoring. They decide to don't do human evaluation. I think it's highly dependent on the content. And there's definitely some content where this RIBS score will be very different. But overall, we worked with Chinese, Japanese, and Korean, and we had to do some tweaks to the metrics to make them work properly. But overall, well, yes.
Can I ask what kind of tweaks?
Some tokenization, like some specific tokenization to avoid some problems with, like, blue and.
But that's already within the engine.
Sorry?
That is part of the engine.
No, not tweaks to the engine, but tweaks to the metrics, which we use to reference-based metrics. And engines, well, for the quality is worse, obviously, than for translating into English. But we have seen no problems in evaluating this quality, I would say that.
So, in other words, your automatic metric correlates with the human evaluation of the Asian languages.
It correlates up to, it's like, if it's like below, let's say, LibOR 0.75, that's very correlated. Then there is like this field, like above 0.75, from 0.75 to like 0.8 or 0.85, where there may be miscorrelations, but basically they are not statistically significantly different, these automatic scores anyway. So when you do human evaluation, you see different ranking, but it's very evident ranking. And automatic score does not show this ranking, because in automatic score they are just very similar. Yeah, that's for sure. That's what we see. But we haven't. I would say that we haven't seen a situation when automatic score is high, and human reviewer says it's worse than this engine with bad score. We haven't seen that.
Anyone else? Over here. I was just reading an article about how the whole website for the Osaka, Japan train system had to be taken down because all the English translations were wrong. They had blind faith in their new Microsoft MT system, and they didn't try to read it.
Oh yes.
All the stations had funny names.
I've shown you this mixed letters, and imagine what it leads to in case of Japanese. I might guess.
Well, I kind of have too many questions. So I think it was interesting that maybe now the people who we use for different tasks may actually change. Maybe we will now have our requesters evaluate the quality. So if the clients that we have are happy with the quality, why should we throw post editing at it. Or we might have our translators do, or our reviewers do the translations, because now they can be more productive because the machine takes care of a lot of things. So that's kind of where my thinking is going, and that was something that I think you also mentioned, so that is really interesting. So now I like the quirks section, and so do you know if anybody, I mean, I think you mentioned a little bit Spanish, so was that the training, was that to clean up the source text? Because what I noticed, if there are any spelling errors in the source text, it's really interesting what the engine does with those errors. It tries to guess what it could be. Do you have any insights? So I think that's my specific question. What happens, or if there are any efforts that you do somehow a fuzzy match on the source language and
the thing is that yeah, they typically, most of the engines, they work on a word level, so they generate words. So an empty output, it doesn't contain like spelling errors, except this one case. So they're doing some guess of what was in the source. We recently seen, as I mentioned, one engine which does almost transcreation, meaning that you give it like a tech cloud, and based on this tech cloud, you have careful description of the item, which seems, I mean, it looks amazing. So it tries to fix a lot these problems. Typically, it just tries to, it's like, probably like human translator, it tries to make sense of what they heard and produce good fluent translation. They're not trying to reproduce, except maybe movie translation, right? They're not trying to reproduce, mistakes in language.
And then I had another question, but maybe it's just my ignorance, but if you use neural machine translation, does the algorithm already change or adapt based on machine learning while a translation is done, or do you really need to train the engine? Or
there are different engines.
Yeah.
One thing maybe which I haven't shown, how much time does it take to train the engine, which ranges from instant to 24 hours, probably. And there are engines which adapt on every sentence, like Modern MT, I think Lilt, if it's still available, because they pivoted into being an LSP, maybe it's not available, I don't know. And maybe Kantan has this technology. I think I heard something about that. I'm not sure. So then it's sort of instant. However, it's not as instant as you think, because if you have 500,000 sentences, then doing just sentence by sentence adaptation will take some time.
But that could be a problem, right? Because if you have a large document and then it adapts sentence by sentence, then it might come up.
I think it's more a question to LSPs, because I have a feeling that you don't want to adjust your engine after translator made the translation. You want to wait until like review is done and this is accepted before actually updating the engine, because maybe this translator just projects Google Translate without edits, and then all your fancy DomainAdaptive NMT will be just spoiled. That's actually a huge problem for MT vendors, because when they're doing their internal evaluations for them, they contract agencies, and they need to make sure there is no bias related to different MT engine. Super hard to do. So, I'm not sure in every case it makes sense to update after every sentence. I'm not sure.
Any other questions?
Yeah. I do want to point out that your laptop is about 10 minutes fast on its time. Its clock is 10 minutes fast, so that may be why some people got worried there.
Oh, really?
But we we do need
How
to.
did it happen?
That doesn't mean we have more time for questions. Does anybody want to ask a final question? Okay, because we need something profound. Oh, no? Okay.
So with the traditional translation review, you continuously train your translators and give them feedback when they're not like adopting to your style. But with the machine, we have a decent model that's deployed, and we do some post editing, maybe very light post editing. But how often do you have to like retrain that model to adapt better? Or
That's a good question. I mean, when you have reasonably more content, and it's something, you see, there's a learning curves. So I think that if you're on this upward slope, it makes sense to make it faster, because what we see, the most adaptation happens in like first 10,000 seconds. And then it sort of improves. So I think if you have a little bit of data, if you have twice more data, then it makes sense to adjust. But if you have already 1 million segments and you have 10,000 more, you just need to look at the numbers, because it's expensive. So we recommend, I would say you need to look at a different thing. Technology develops very rapidly. So if you selected your engine, you trained it, it's highly likely half a year after, you may need to look at some different people who think that they are losing a little bit, they just invested more money and move forward. So just look at the news. Look, typically if somebody writes a press release, there's something to check. Did they really improve? How much? And the two factors: your increase of your data and change, like pace of technology. But I can't tell you a number.
Okay. Well, thank you for making the drive down here, and we hope to have you back soon.
Thanks.
Okay.